In Essential Task 4.3, we are going to talk about how psychologists design tests. In the context of this part of the unit, we're going to be talking a lot about how psychologists design intelligence tests, but many of the concepts that we apply now also apply to things like personality tests. The concept map that we're talking about today is in combination with the concept map that we're talking about in 4.4. What you see under design on the left incorporates all of the elements of 4.3. On the other side, you see the terms of the word good test with the terms reliability and validity. That is going to be covered in Essential Task 4.4. So right now, we're only going to be talking about the design portion of the broad category of psychometrics. The column all the way to the left, or all the way to the right, rather, looks a little bit longer due to some of the pictures. But nevertheless, I'll allow you to pause the video now and copy down the yellow portion of the Essential Task. We'll start, though, all the way at the top under design, introducing the term psychometrics. This isn't the first time that you've seen this term because it is partially the name of the unit, but the term psychometrics refers to a subcategory, a field within psychology, involving the measurement of human abilities such as intelligence and other attitudes or traits like personality in a very scientific and precise and quite often mathematical manner. Essentially, psychometrics is the term that we use for individuals whose profession involves designing well put together and valid intelligence tests, personality tests, etc. Choosing the questions, determining the methods of standardizing, comparing results across numerous random selected groups of people, and determining whether or not the test actually measures what it intends to measure. All of that involves the field of psychometrics. So if you really enjoy psychology and you really like math, there is a potential career path. You could become a psychometrician. But when psychometricians design tests, they have to take into consideration a variety of elements, from the purpose to some demographic issues, and then worrying about a process known as standardization. We'll start, though, with test purposes. As a student in your 12th year, as a senior, you've definitely taken a variety of standardized tests. There's a potential that you've taken either the PSATs or the SATs. And then there's also potential that you've taken, if you've lived in Massachusetts your whole life, the MCAT. Those are examples of standardized tests. Those two tests illustrate one of the first decisions that a psychometrician needs to make. Should this test be timed or should it be untimed? The SATs partially evaluates your ability to answer those math and English questions with time as a variable. Some of you might feel rushed while taking the SATs, and that is partially by design. Other assessments, though, with things like your biology knowledge, is really an assessment of your overall success in learning biology. And as a result of that, because the intent is only to study your knowledge of biology, that is a test that is untimed. So the MCAT is an example of an untimed test. Those are differences in what we call speed of processing. The SATs is designed to determine your preparedness for college. Speed of processing has been determined to be an important element of that, so that test is timed. The MCAT, on the other hand, has a little bit of a different purpose, and as a result, for the most part, it is untimed. Now, obviously, you can't spend 20 years taking the MCAT. There is some type of cutoff point if you sit there for hour after hour not answering the questions. But if you do not finish in the time normally allotted, you are allowed to continue taking the test as the day progresses. The next consideration that psychometricians need to make is to determine whether or not it's going to be an abstract or a verbal assessment. There are some puzzle-based intelligence tests that we're going to look at this unit. We're going to evaluate one while talking about this concept map. Those are abstract. Those are puzzle-based. But there are also numerous examples of verbal assessments, and you've certainly taken a variety of those throughout your career. Every standardized test that you've taken has likely been verbal. All the assessments that you've taken in this class and will take in this class, including the AP exam, is considered verbal. Virtually every test that you've taken in school has probably been verbal. However, there are entirely puzzle-based assessments that are more abstract, which we're going to be talking about as the unit progresses. The next consideration are to identify some sort of cultural issues and demographic issues that are important to note while producing standardized tests. The first is to ensure that your test is what we call culturally fair, or to ensure that you have a culture fair test. There are some IQ tests that can be critiqued because they incorporate questions that might not adequately gauge the intelligence of all test takers due to some type of sociocultural or educational difference between the test takers. And as a result, there are nonverbal tests that exist, like the question that you see below, that are designed to try and evaluate intelligence, evaluate their topic of interest in a way that's fair to all cultures. And you actually see a little bit of this on the AP exam. You're likely going to notice that a lot of the names incorporated in the multiple choice and FRQ section are some pretty culturally diverse names. They're not all sort of generic North American names. You're going to find a lot of names from different cultures. And that's partially to allude to the fact that not only Americans take the AP exam, people from all over the world take the AP exam. And in addition to that, a few years ago, they asked an FRQ question, and it involved conducting this sort of study at your house on Halloween. But if the AP exam actually used the word Halloween and exclusively used the word Halloween, well, certainly individuals who grew up in North America who culturally celebrate Halloween in October would understand what the question was asking. But if you came from a different culture that certainly doesn't celebrate Halloween, you'd have a lot of difficulty understanding the context of the question. As a result, instead of actually saying Halloween, the College Board used the phrase something along the lines of an annual holiday where people dress up in costumes, go around and gather candy from different houses. It described Halloween instead of just using the phrase Halloween. That was an example of making sure that the test was culturally fair. So anytime you evaluate your questions, ensure that you're not talking about unique American holidays or ensuring that the names that are used are a little bit more diverse. Those are all considerations that are made when determining if you have a culturally fair test. Because if your test is supposed to be an IQ test, it should study IQ, not cultural differences. The next is to be keenly aware of what's called the stereotype threat. This occurs when there is some type of negative stereotype about a group. That can be gender, that can be race, that can be ethnicity, that can be religion. And as a result, that negative stereotype might contribute to a worse performance on the actual assessment itself. And oftentimes that has to do with some type of expectation. So it's important to counteract any of that by ensuring these types of negative stereotypes do not exist. A common one, and these studies have been shown, that if you tell someone women do poor on this test or men do poor on this test, groups that are told that prior to taking the assessment are going to do worse relative to if they were told nothing at all. So it's really important that when you're giving some type of assessment, you don't frame it in such a way that you can set up failure or at least some type of worse performance out of your test takers. If you have an IQ test, you want to authentically evaluate IQ. You don't want to produce feelings of anxiety that might result in poor performance as a result of presenting some type of negative stereotype. Final thing to talk about is all the way to the right under the box standardization. The term standardization itself is the process involved in putting together the steps in how the test is actually going to be administered. Because if you're going to give a standardized test like the MCAS or the AP exam, it's critical that every single person takes the test under virtually the identical conditions, meaning you don't want to suddenly give two different groups of people in two different states two incredibly differing experiences on the day of the AP exam, because one condition might favor one group over the other. One environmental factor might favor one group over the other. So it's pivotal that all test takers experience virtually identical experiences. That way, the only variable that differs between all of the test takers is their knowledge of the information. If you fail to standardize your tests, you don't really have the ability to compare test takers, because at the end of the day, you could always critique that maybe one test taker experienced a different condition to the other. The process of standardization is really the only reason standardized tests themselves have any meaning. Without standardization, the results really, quite frankly, can be meaningless. So, for example, they recently changed this, but years ago, only a couple years ago, when the AP exam ended in Massachusetts on the East Coast, there was about a 20 to 30 minute window of time before West Coast people like in California took the AP exam. And up until recently, they kept the FRQ questions the same for the East and West Coast. So there was about a 20 to 30 second window of time where people on the West Coast frantically tried to find out the FRQ bullets so they could study them, memorize them, and know them before taking the assessment. That's obviously incredibly unfair to those on the East Coast. And as a result, in my opinion, for many years, there was a huge flaw in the standardization process. The East and West Coast did not take the test under the same conditions because members of the West Coast and students on the West Coast, in some cases, knew the FRQ bullets ahead of time. Or they could just check Twitter, which is often filled with memes of students who are sort of breaking the College Board rules. And as a result, the conditions were different. In the aftermath of that, the College Board has made a series of changes, including shifting the questions for the East and West Coast to alleviate this problem. Now, as a result, East Coast students are compared with East Coast students, and West Coast students are compared with West Coast students. Now the conditions of those two tests are similar for all the test takers, and now we don't have to compare East to West Coast students who, for all intents and purposes, experience two very different conditions. A group of students that know the FRQ bullets and a group of students that do not. You might recall this exact text. If you've grown up in Massachusetts and taken the MCAT, you've seen it, but there's a reason that teachers have to read a very distinct prompt to all students before taking the MCAT and also the AP exam. It's to ensure that all students hear the exact same directions. Therefore, all students experience the same environmental conditions and then ultimately take the exam under the same conditions as everybody else. As a result, we can compare MCAT scores in Massachusetts to Springfield, to Wilmington, to Tewksbury, and Boston, and everywhere in between, because in theory, all students have experienced the exact same conditions. In some cases, that means the exact same questions. In other cases, depending on the assessment, like SATs, the exact same time, and certainly always the exact same directions. You would feel very upset if you learned that another group of people took the SATs and their prompt, or the person that gave them the assessment accidentally gave them an extra 5-10 minutes. You would say that's unfair. So as a result, we keep the conditions the same. No matter if you take the SATs in Massachusetts or California, the exact same time is going to be provided to all test takers. That's the process of standardization, and it ensures the results of your exam actually mean something. Because otherwise, quite frankly, they're meaningless. You can't compare two students if they experience two different test conditions. So we got 2 boxes remaining. This one looks a little bit taller than it is because of some of the visuals, and then a small box at the bottom. So when you look at test scores, we often use distribution graphs. This is the second time that we've seen distribution graphs in this course. And it's really quite easy to look at this. This is an example of a distribution graph for temperature in this case, average annual temperature. And you can see the number of occurrences on the y-axis with the temperature on the x-axis. The higher the graph, the more that score occurred. As we discussed, this is a little bit of a review of material from Unit 2. But as we discussed, there are 2 different types of distributions when we talk about outliers, either positive skews or negative skews. And it's kind of the opposite of what your brain wants. So again, looking at this, the green, the one that's shifted towards what looks like higher numbers, is actually a negative skew. It's distorted like this because there's an outlier, like a 0, that's pulling the average lower. And then on the opposite side, that blue one is actually a positive skew. I know that looks like the values are closer to 0, but that's not how it works. You're looking at the tail side, remember, the side over here. It's a positive skew because there's some type of outlier that's pulling the average way higher than it's really representative of the actual scores. So when you're looking at the results of something like a test administered in class, you can get results that look like this. Under the condition of a positive skew, the one here again in blue, the mean is way higher than it really should be. This mark here indicates the mean. On the green one, the mean is way lower than it really should be, again, because there's an outlier. The tail is over here. There's also multimodal or bimodal distributions when there are multiple peaks. We talked about this again back in Unit 2, meaning there's a bunch of people that got above the mean, a bunch of people that got below the mean. We call those multimodal or bimodal distributions. So again, that was when it had those 2 peaks. What might be a little bit different, though, in what we're going to focus on today, information that we did not talk about in Unit 2, is this last part. And this is something that I would like you to copy down. I would like you to try and copy down this perfectly symmetrical, what we call bell curve. This bell curve is an example of what it would look like if the mean, the median, and the mode for one test all were exactly the same. It would make it so that the peak here at the very top is also the value of the median and is also the value of the mode, because again, the highest point indicates the mode. But it's also the average. So it's all 3 of the central tendencies, mean, median, and mode. And as a result of this perfectly symmetrical graph, there's a variety of things related to intelligence testing that we need to be aware of. First is that, again, the mean, median, mode are all the same. That, by definition, is what makes it a normal distribution graph or a normal distribution curve, sometimes nicknamed a bell curve because it, again, kind of looks like a bell. Most major intelligence tests maintain these 2 standards. So these aren't just 2 random numbers that I'm picking as an example. Most major IQ tests are designed to produce these 2 results. So you do need to know these. These aren't random numbers for an example. But typically, the average score on an IQ test is 100. That's designed on purpose, meaning if you have an IQ of 100, it means you have an average IQ. You have an average IQ relative to everybody else. If you have an IQ of 105, you have an above average IQ. And if you have an IQ of 95, of course, you would have a below average IQ. Intelligence tests are actually designed and evaluated to be a certain level of difficulty to produce an average score of a 100. And as we talked about back in 4.1, IQ tests, if they are never changed, would actually start to trend upward. IQ scores have been going upward over time, called the Flynn effect, meaning we've actually had to make IQ tests more and more challenging over time to keep resetting the average back down to 100. In addition to that, the standard deviation of your typical IQ test is always 15. That's true for all major IQ tests. The Wechsler Adult Intelligence Scale, the General Intelligence test that we're going to look at in class, the default for all major IQ tests is to produce a standard deviation of 15. And as I'll show you in just a few moments, that allows us to use some standard deviation principles to make some determinations about that test. So there are two standard principles. The mean is 100, standard deviation is 15. That is the case for all the IQ tests that we talk about in class across the board.